Today we are moving into chapter 4, and chapter 4 is going to deal with radicals for a while, and then we're going to move into rational expressions. So, this first one says, find the cubed root of 1,000. Now, you might know that in your head. If not, then you just factor 10 times 100, 5 and 2, 10 and 10, 5 and 2, 5 and 2. And then instead of looking for pairs like we do with square roots, we're looking for triplets. So we can bring out a set of 5s, we can bring out a set of 2s, and there's nothing left on the inside. So the outside is 5 times 2, which is 10, and then technically it's the square root of 1, but we don't need to write that. So the cubed root of 1,000 is just 10. 10 times 10 times 10 is 1,000. Okay. So what about fractional exponents? Well, in a fractional exponent, this is an exponent, and this is a root. So if I rewrite this, it would be 81, and it's going to be the fourth root of 81 to the first power. Now, you can either put the first power here, or you can put the first power there. It doesn't really matter. Well, sometimes it matters, but it's not going to be an issue in this class. And sometimes putting it on the inside is easier, and sometimes putting it on the outside is easier. So for this one, I'm just going to leave it on the outside. 81 is 3 times 3 times 3 times 3. And I need to bring out a set of 4. So I bring out all the 3's, and I get 3 on the outside, and then the fourth root of 1 on the inside. So the answer is just 3. Okay? All right, we'll convert this one. Remember, 1 is an exponent and 3 is a root. So the third root of 64 to the first. 64 is 8 times 8. 2, 2, and 2. 2, 2, and 2. Can I bring out any triples? Triple there, a triple there. So the answer is 4 on the outside and then a 1 left on the inside. Do you understand that? Okay. Let's make it a little bit more complicated. 16 raised to the 3 halves. So 3 is an exponent and 2 is a root. So we have the square root of 16. And then I have to decide, do I want to put the 3 on the inside or do I want to put it on the outside? It doesn't really matter, but sometimes one way is easier than the other. And it depends a lot on, can you take the square root of 16? Yes. So in this case, putting the 3 on the outside might be easier because we can square root 16. So I'm going to put the 3 out here. And the square root of 16 is 4. And that leaves me 4 to the third, which is 64. So the 16 to the 3 halves is 64. So what's really going on here? Well, it's saying what number times itself is 16, and use 3 of those numbers, and we get 64. So we are building a set of numbers, a number times itself that's 16, and then the final answer is 3 copies of that number. Okay. Well, what if we did it the other way? What if we did the square root of 16 to the third? Well, that factors into 16 times 16 times 16, which is 2 times 2 times 2 times 2 times another set of 4 2's and another set of 4 2's. Now we're looking for pairs. So 1, 2, 3, 4, 5, 6, and 2 to the 6th is 64. So it works both ways. Okay. Do you guys want to see another one of those? All right. Well, I'll build my own. What if we had 27 to the 2/3? So we take the cubed root of 27, and do I put the squared on the inside or the outside? Well, does 27 have a cube root? Yes, it's 3. So I'm going to put the squared on the outside. So this is 3 times 3 times 3. Bring out one set. So I bring out a 3 to the front, and I square it, and I get 9. Okay, what's really going on? Well, can 27 be split into the same number times itself 3 times? 3 times 3 times 3. How many of those 3's will exist in my answer? 2 of them, so I have to throw 1 away, and I get 9. So it's not 2/3 of 27. It's 2/3 of the multiplications that built 27. Do you see the difference? 2/3 of 27 would be 18, right? But 2/3 of the numbers that build 27 using exponents would be 2 copies of 3. 3 times 3. Okay. What if we had, let's say 9. No, let's not do that. Let's do 25 to the 5 halves. Ooh, that's going to be a big number. Whatever. So 25 square rooted to the 5th power. What is the square root of 25? 5. And 5 to the 5th. So that would be 5 times 5 is 25, times 5 is 125, times 5 is 625, times 5, I don't know. What is it? A really big number? 3125. So the answer to this one is 3125. Okay? All right. Well, let's see if are they going to give us one that doesn't simplify? No. Okay. Let's go on to the next one. Oh, this one just wants you to convert. So z to the 1/4 is the same as the 4th root of z to the 1st. Okay. What if I have the 3rd root of x to the 5th, 8 to the 5th? What is that going to turn into? 8 to the 5/3. Okay. That's how you convert between exponents and radicals. All right. If I have x to the 3rd equals 216, how do I solve? I take the 3rd root, and that is 2 times 2 times 2 times 3 times 3 times 3. What can I bring out? Set of 2's and a set of 3's, and everything came out, so the answer is 6. Becca, you all right? Okay. How did I know that was 2 times 2 times 3 times 3? Well, I knew that 6 to the 3rd is 216. Okay, what if we have x squared is equal to 121? Take the square root, and the answer is plus or minus 11. Why did the last one not have a plus or minus? It was a cube root, so this one would be plus or minus 11. Okay. What about x squared equals, no, x to the 4th equals 16? We take the 4th root, and we get x is equal to plus or minus 2. Why does that one have a plus or minus? It's a fourth root, if I can say it right. So any even power will create a plus or minus, but the odd powers will not. Okay, well, what if this was a 32? And I factored it, and I got 2 times 2 times 2 times 2 times 2. What can I bring out? Set of 2's. So it's plus or minus 2 times the fourth root of 2. Just like you would simplify square roots. All right. Okay. Same idea here, but now I have a negative. What does a negative exponent do? Flips the base upside down. So if I had 32, maybe, if I had 32 raised to the 2/5, that is going to be the fifth root of 32 squared. Right? But if I add a negative to this, then instead of a 32 in here, I'm going to have a 1 over 32. So a negative exponent flips the base upside down. Okay, well, what is the fifth root of 1? It's just 1. What times itself 5 times is 1? 1. And what is 1 squared? 1. So the top is just 1. And the bottom is going to be the fifth root of 32 is 2. And 2 squared is 4. So the answer is 1/4. Now the other way you could do this is you could ignore the negative and solve that, and we get the answer of 4, and then introduce the negative, which is going to flip that upside down to create 1/4. So you can either flip it and solve, or you can solve and then flip. All right, next one. This negative here is just going to flip that fraction upside down. So 1/9 to the negative 3/2 is exactly the same as 9 to the 3/2. And 9 to the 3/2 is just the square root of 9 to the third. The square root of 9 is 3, and 3 to the third would be 27. Got it? Is it Monday? Because you guys are a little sluggish. All right. What's next? Same idea here. So v to the third is 20. We take the third root, and I get v equals the third root of 20. 20 is 2 times 2 times 5. What can I bring out? Nothing. So the answer is just the third root of 20. Okay. 81 is 4 copies of 3. What about that negative? There's just going to be a negative on the outside. So I pull out a 3, and I get negative 3. Okay. What about a negative on the inside? It's not a real number if the exponent or the root is even. So what is the third root of negative 8? What times itself is negative 8? Negative 2. So the answer to B is negative 2. because negative 2 times negative 2 is positive 4, and positive 4 times negative 2 is negative 8. But what if I put a negative inside the other problem? That becomes an I. So for A, if I put a negative on the inside, then I pull out a 3 and an I, and it would be negative 3I. So negatives on the outside just make the answer negative. No big deal. Negatives on the inside make I's if the root is even. If it's a third root, fifth root, seventh root, then you can take the root of a negative, and the answer will just be negative. So what if I had negative fifth root of negative 32? Am I going to get an I? No, because it's a fifth root. So what is the fifth root of negative 32? Negative 2, but there's a negative on the outside already. So the answer becomes plus 2. So I's are created whenever you have a negative inside an even root. Does that make sense? Okay, same idea here, but now we just have to convert. So the first one is the third root of negative 8, which we've already said is negative 2. And then the fourth root of negative 256. The fourth root of 256 is 4, and the fourth root of a negative is I. And I dropped my stylus. All right, last one. Okay, so here we have an equation that needs to be solved. Subtract 48, x plus 4 to the third equals 48, negative 48. Take the third root, x plus 4 is equal to the third root of negative 48. Factor that, 4 and 8, no, 6 and 8, 3, 2, 2, 2, and 2. What can I bring out? Bring out a set of 2's and the negative. So here we have the option of leaving the negative in or taking the negative out. You always take it out, whether it becomes a negative or it becomes an I. So never leave a negative inside a root, whether it's an odd root or an even root. So on the outside, I get negative 2, third root of what's on the inside? 6. And that's equal to x plus 4, so I subtract 4. And I get negative 4 minus 2 times the third root of 6. Okay. Get to work.